I'm going to point out here is homework questions. So you do have 2 homework sessions due, right? 3, 2, and 3, 3. Yep, there are 2 homework sessions due tonight, 3, 2, and 3, 3. Does anyone have any questions for me? There are 2 homework questions due. 3, 2, and 3, 3. Anyone have any questions for me? You can either talk to me or voice out or type in the chat room. Anyone has any questions for me on 3, 2, and 3, 3 that is your homework due tonight? If you do, please do type it out. So I'm going to point out to you guys about your test, because you will have your first test on next Wednesday. Okay, so I'm going to say that. So your first test is on next Wednesday. So this coming Wednesday is going to be in CLA 116. You are so if you don't have, you're allowed to use a scientific calculators. If you don't have one, let me know. It's going to be from 2 to 3:30 p.m. Next Wednesday here. So what class is it? 2? Yep. So make sure you guys get to go to CIA 116. You do need to have mask. Wear your mask or face shield or something else. Face mask or face shield. I don't know about, yeah. Make sure you come in, and I just start doing the review for the test just now, so you will get the review later today in D2L and your email. So I will send it to you guys. So make sure you guys study for the test. The test consists of 26, 27, 31, 34, 41, and 42. So today we will cover up 34 and 41, and then 42 will be due. We'll talk about 42 on Monday. So we do have class on Monday, the 13th. So anyone have any questions for me before we move on to 34 and 41? Okay, so so make sure you come to please come to take your test. Don't forget, if you are not feeling well or something else, you have to email me. This is very important. So the test is on CIA 116 from 2 to 3:30. This test is around like let's say around 14%, around 13-14%. So don't miss it. Okay. All right, so let's talk about your chapter 3.4 here. So last time in 3.3, we talked about doing syntactic division. This is very important. Hopefully you remember how you perform syntactic division. And the only thing that we concentrate here is when you do your syntactic division, we want to have your remainder to become 0. Okay, this is very important. So if your remainder is 0, then we say that the x minus k is the factor of the polynomial. So this will be what we will talk about in 3.4. Now we're talking about the zeros of a polynomial function. So there are a few theorems you need to know. One of the theorem, this is something you, so this is something that you just understand this, you don't need to memorize this. So one theorem is called fundamental theorem for algebra. It says that if your polynomial has a degree of n, then it has at least 1 0 in a complex system. So what is this complex theorem of algebra says? It says that if you have x to the power of 4, then you can have up to 4 zeros. Zeros means factors or solutions. Some of them can be real and some of them can be complex. And when I say complex, means I. Okay, so so when you have 4 zeros, usually it can be all 4 complex, or it can be 2 real, 2 complex, or it can be all 4 real. Now, what is the meaning when I say the zeros are real zeros? What are real zeros? Let me start with the real zeros first. Real zeros are zeros that can only take in a real number form. Real number form in this case, like numbers 0, 5, 9. It can be fractions 4/7. It can be decimal 2.67. It can be square root number, like square root of 5. It can be pi. So it can be a lot of numbers as a solution, but it cannot be it cannot be complex. Okay, so when I ask for real zeros in the test, that means I just want to I want all these numbers. Your answer can be 0, 5, 1. So if you have a complex numbers as your solution or your zeros, you cannot include it. Okay, but sometimes in the test I ask you for all zeros. All zeros means real zeros plus complex zeros. So that means that if in the test, if I ask for give me all zeros, means any zeros is in your solution, including the including the complex zeros. So make sure you guys know the difference between real zeros, all zeros, and then we got a little bit more to add on to it. So this is something you guys need to pay attention, especially when you're doing my test, because a lot of students doesn't know the difference between real and all zeros. Same thing in your homework. If your homework asking for real zeros and your answer came out to be 2i or 3i or negative, something like that, you cannot include it in your answer. Okay. Next theorem. This is very important. I'm going to put checkpoints on it. So I'm going to put 3 checkpoints on it. Means super important. So this is called a rational zero test. What is a rational zero test in this case? It says that, this is very important. So if you have a polynomial function and you can find the rational zero with a form of P over Q, where P and Q, let's say, where P in this case is a factor consists of A0 and Q is a factor consists of a factor of leading coefficient of an. So this an, that means the leading coefficient of your polynomial, and the a0, the constant term of your polynomials, will determine a possible rational zero. How we figure out is you take the p over q, you divide it, and you need to put plus and minuses on it. So this is, I forgot to add plus minuses. So that means that your possible rational zero can be plus minus that number. So now I'm going to add on to this list called a possible rational zeros. So if a question is asking you to find the possible rational zeros, you have to use the plus minus p over q. Now, I am okay when you do in my test plus minus 3, plus minus 2. I take that in your test. If it's correct. But in your homework, you cannot. They don't take plus minus. So you have to do 3 minus 3, 2 minus 2. So they don't do plus minus. So they don't accept plus minus 3. No. So in the test, don't do plus minus 3. No, in the homework. In the test, do plus minus. So that would be good. So the question is, what is rational zero in this case? So rational zero is actually zeros can be in the form of fraction. Okay. Example is like 0, 5, negative 2. Any fraction 3 over 4, or any decimals that is terminating, like 2.67, it terminates, or 3.3, any numbers that is repeating. Okay, so that repeat. So all these numbers can be written down as a fraction. So that is called the rational zero. So the only number cannot take from here is square root, pi, and I. So you cannot take any, the only rational zero that you cannot have is if you have any square root of 3 or square root of 5 or pi form or I complex form. So, but any other numbers like decimals that is repeating, decimals that terminate, any fractions, any whole numbers, any integers, that's form of rational zeros. So let's talk about this rational zero. This is the main cause of this chapter 3.4 here. So why we are doing this? The reason why we are doing this is because once you get a very big polynomial like a power 3, power 4, we do not know, we cannot factor it. Now, power 2, we can factor things, we can figure out the zeros. But once you reach anything above 2, like 3, 4, 5, you cannot, it's very difficult to figure out what factor it. The only thing you can try it is you perform syntactic division until your remainder is 0. So we did in the last section here, you did quite a few of syntactic division. You find out that not a lot of them have a remainder of 0. So this follow, you have to make a remainder of 0. So there's a lot of work, a lot of trial and errors, what we call. So what we do here is we use this rational zero test to just eliminate, to figure out the possible rational zeros. So that means that these are the possible zeros. So we can actually then use the syntactic division to figure it out. Okay, so I'm going to show it to you. What do we mean by that? Okay, so we talk about the first question here. Okay, so this is 3.4. So this question is asking us to use the rational zero test to find the rational zero. So the big keyword here is rational zero. So as you remember, rational zeros means it cannot be square root, it cannot be pi, it cannot be I, complex number. So what we do here is, in order for us to use a rational zero test, which is P over Q, plus minus, first thing first is the P in this case, if you, P is the factor of a constant term. That means the constant. And Q in this case is your leading coefficient. Okay, so if you look at this formula, this polynomial function here, can you tell me what is your constant term here? Look at this and tell me your constant term. Ignore the plus, negative, or plus. What's your constant term here? Andrew, Andy, Avery? Last term. What is your last constant term? No x.
12.
12, yes. This is your constant term. And what is your leading coefficient? That's your Q. What number in front of your x cubed? The leading?
1.
1. Now, can you give me the factor for 12? When I say factor, means what times what is 12?
6, 2, 3, 4.
So 1, 2,
12, 1.
3, 4, 6, and 12. Right? So 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. So these are the factors for 12. And ignore the negative. Okay, don't worry about that. What is the factor for 1? This is easy, just 1. Because the only factor goes to 1 is 1. So what do? Is we just divide this out. So what you're going to do is you take 1. What is 1 divided by 1? Is 1. 2 divided by 1 is 2. 3 divided by 1 is 3. 4 divided by 1 is 4. 6 and 12. And don't forget to put plus and minuses. So this is called the possible rational zeros. So in a homework, you cannot write this. You have to write 1, -1, 2, -2, 3, -3 with commas separated. So it's a lot. You have to type in online. In the test, I think this. Okay. So this is called a possible, not the rational zero. Now the question wants us to find the rational zeros. So in order for us to find the rational zeros, you have to take one of these numbers, put in here, and you have to take this polynomial and perform syntactic. Hopefully you will get a 0. So this is a little bit like trial and error here. So if you are lucky, one number, you will get up with a 0. If you are unlucky, you will erase until you get a hole in the test, because you've been erasing nonstop. So I would really recommend you to use pencil in your test. So anyone wants to feel lucky today, what number you think you should try? One of these numbers that we list here. They're all possible. Anyone? And the syntactic here is going to be 1, -9, 20, and -12. Anyone wants to give a number? Make sure you pick from this list. Don't take 5.
Let's do 6.
Okay, you guys, I always do smaller, like 1 or 2. All right. Since Soksa says 6, you guys are gonna do 6. You guys know how to do syntactic, right? I want you guys to perform syntactic division on this of this 6. Okay, we do 6 here. And our goal here is to get your remainder as 0. If your remainder is not 0, 6 is not a 0. Okay, so we are looking for zeros in this case, rational zeros. So do syntactic division here. Everyone do it. Because in the test, this is what you have to do. And in the test, because you only got an hour and a half, I don't give you that many zeros. I probably give you like 3 or 4 to pick from. So you got, hopefully you pick one and you got it. Make sure you guys know how to do this. You drop the 1, right? As usual.
Yep. And then it will equal 6.
6.
And then -3.
And then what is this times that?
-18.
Oh, that's good. Very good. Yeah. And then add this up.
2. And then
Multiply
12.
this. Well, very good. This will came out 0. Perfect. So what we do, yeah, good. So 6 is a 0 in this case because it is rational, because the remainder is 0. So what happens usually, this is the stuff I want to tell you guys. So if you have a power 3, you just need to perform syntactic division 1 time if you have a remainder 0, because the remainder, the quotient that we have here is going to be in power 2. And since this is a power 2 form, then we can actually factor this, or we can use quadratic formula. So we do not need to perform syntactic division. So the one I want to tell you right now is if you have power 3, you only perform syntactic division 1 time if the remainder is 0, and then you will get a power 2, and then this fellow you can either factor it or you can use syntactic division. But what happens if your polynomial function is a power 4? Then you have to perform syntactic division how many times? You have to perform syntactic division 2 times, because power 4, if you perform syntactic division and you got a remainder of 0, that power 4 will become power 3. Power 3 you cannot factor or cannot use quadratic. So you have to reuse that power 3 to perform syntactic division again, like what we did here, till you get a remainder of 0, then that power 3 will become power 2. And then once you reach power 2, then you can do factor or quadratic. So what I'm telling you here is, in order for you to find the zeros, the more higher power is, the more work you have to perform until you reach power 2, x squared. Then you can either use factor or quadratic to find the other 2 zeros. But otherwise, you have to perform syntactic division. Anyone know what's a factor for this one? You can factor this one, right? This is easy to factor.
X minus 2, X minus 1.
Yep. X minus 2 and X minus 1. And what would be your rational zeros in this case? X is
2.
2. X is
1.
1. And X is, don't forget.
0.
No. What did we divide early on with syntactic? Your 6. Okay, so do not forget that this is a power 3. Power 3 have how many zeros? 3 zeros. Okay, so and the third 0 is always the one that you divide with, the one that we're here. So this is what we call as rational 0. So if you look at these numbers, is this number came out in this possible rational zero? Is 126 in here? Yes. Okay. So if you don't want to pick 6, you can also pick 1, or you can also pick 2. So either one of these numbers, when you divide syntactically, you will get remainder of 0. So this is how we find the rational zeros. Questions? Anyone have any questions? Okay. So usually in the test, I'll only give you either power 3 or the highest is power 4. I'm not going to give you power 5 or 6 because it's going to take you 2 pages long to do it. So power 3 is really this long. Power 4 is like double of this. And power 5 will be even longer. So let's try number 2. Can someone tell me what is your P and what is your Q?
P is 24.
Q is
9.
9, right? The first and the last one. So P is the last one, Q is the first one. Don't forget. And what happens if you switch these two numbers around? Everything is wrong. So can someone tell me what is the factor for 24? What times what is 24? 1 and 24?
1, 2, 3.
3, 4. 4 goes in 24, right?
Mm-hmm.
Can 5? No, right?
No.
6, because 4 times 6 is 24. So you can do this way, 4 times 6. 3 times what is 24?
8.
And then 2 times
12.
12, and then 1 times. So you always, once you get into middle, 4, 6 is 24, then you kind of like pairing up 3 and 8, 2 and 12, and 1 and 24. How about 9? What is the factor for 9? 1,
3 and 9.
So these are the factor for 9. So now what you do here is you have to divide this out. Now dividing this is called the possible rational zeros again. So I'm very stressed on this is because a lot of students didn't read the homework question well, and they type in, give me the possible rational zeros and give me 216, and they mark you wrong because the possible rational is not 216, it's 1, 2, 3, 4, 6, 12 plus minus. So how do we do this? You take all this divided by 1, so you get 1, 2, 3, 4, 6, 8, 12, and 24. So you take all those divided by 1, you still get back there. And then you do the same thing, you take all this number divided by 3. So you got 1/3, you got 2/3. 3 over 3 is 1. We already have it here, so we do not need 2. 4 over 3, we need 4/3. 6 over 3 is 2. We have it. 8 over 3, we need 8 over 3. So this one is even long list here. 12 over 3 is 4. We have that. And 24 over 3 is 8. We have that. So this is all over 3. Now we do over 9. So take all this over 9. So you got 1/9, 2/9. 3/9 is 1/3. We have 1/3. 4/9. We don't have 4 over 9. 6 over 9 is 2/3. We have that. 8 over 9. We don't have 8 over 9. We do that. 12 over 9. 12 over 9 is 4 over 3. So we have that. And 24 over 9 is, I think it's 8 over 3. So this is all of it. And don't forget, you need to put what on it? A plus and minuses. So this is what we call as possible rational zeros. So in the test, you do like this. Again, I'm not giving you that many choices. In your homework, you're going to type every single one of these twice because you have to put plus and minuses on it. So if they mark you wrong because you forgot to put a comma in between them, just send me an email or just email me. Just ask ask the teacher. I will give you back the point because you probably missed a comma in between them. So that's why they mark you wrong. So anyone? So what we do now is we're gonna try to perform syntactic division here with these numbers. So that will be 9, -9, -58, 4, and 24. And don't forget, this is power 4. You have to perform this twice. So anyone feel lucky today? It's Wednesday, you can get your Powerballs. Out of all these numbers, pick a number, put in here, and we want to get a 0 as your remainder.
3.
Suksa, you're good. I do not know. So I'm going to try, you guys try 3. So go ahead and try 3 and make sure your remainder is 0. If your remainder is not 0, then you have to try another number. Go ahead and try this. This is 3.4. Let me save this. The 3 works. I'm going to call someone else besides Suksa. Suksa, give me all the answer here. Henry.
No, it doesn't work.
It doesn't work?
No.
Okay, then 3 doesn't work, then we have to try it. So I just cross 3 like this because don't forget, if 3 doesn't work, doesn't mean negative 3 doesn't work because this is plus minus. So 3 doesn't work, negative 3 can work. So someone give me another number besides 3. Now, because this is way too much numbers, right? Look at that. Look at all the zeros you can try here. So usually it comes with a graph. So sometimes in your test, because I do not want you guys to figure out, you know, look at this. You're gonna play around with this for like 2 hours, right? To figure out the 0. So sometimes it will come with a graph. So so like this graph. So I show it to you here in the test. So the test provide you a graph because it's so you do not need to try every single one of it. So this is the graph that I just type out the equation here. Okay, so this is the, oops, sorry. And this is a graph that pop out. Can someone tell me what zeros? Oh, 3 works. Are you sure? This is 3, right? See, so when the graph came out, what you do here is you just look at your x-intercept. So beside 3, what else works? Negative 2, right? This 3 works, negative 2 works. So I want you guys, Suksa, is that Suksa say? I really want you to try 3 again. Let's try 3 together. So you get 9, right? Henry, what you get? 3 times 9 is? You guys begin to participate here.
27.
Is that Henry or Suksa? Suksa, you didn't answer me. I want to ask someone else besides Suksa because now you guys are sleeping here, huh? Henry, what you get when you add these 2? Henry?
22.
Suksa?
He typed it, I think.
If you type it, oh, I'm sorry. So don't forget it's 20, not 18. Then multiply this with 3, you get what? 66, right? Add it, make sure you have a calculator. What you get? Henry, one more time. Negative 58 plus 66. Yep, good. And then multiply this by, where copy that? Yeah. 3 times 8 is 24, right? That doesn't work. 3 doesn't work. Do I copy this one right? Yeah. Do I copy the graph right? That was weird. 9x4 plus, I'm going to check my equation. 9x4, do I copy this right? 9x4 minus 9x3 minus, yep, plus 40x. 3 works. Why this 3 doesn't work? Do I make any mistake here?
-9, 27.
Oh yeah, it's not 22. Hello,
Should be
18. Sorry
18.
about that, Henry. Thank you. This is 18, not 22. And 3 times 18 is what? Thank you for.
54.
Thank you. He's.
54.
And then we get what? Negative
4.
4, and then this is negative 12. Very good. Very good. Negative 8, negative 24, and you get 0. Perfect. Good, Ari. Thank you, Ari, for correcting me. And Henry, thank you for. You should wise out, Henry. I make a mistake. So what happened is that this is a power 4. This is your 0. So what happened is this power is power 3. So you do have to perform another syntactic using this fellow. Don't start from the original. Start whatever you left over. And since the graph I give it to you, can someone tell me another 0 from this graph besides 3? You can try what? Because these are all fraction. It's icky, right? So usually in a test, you can tell this is 3, and we're gonna try with what? -2, because this is a -2. So what you do in this case is perform one more time syntactic division with -2. Definitely got a 9. This is easy. -2 times 9 is what? -18. This will be 0. 2 times negative multiplied 0 is 0. This is -4. This times this is 8. You get what? 0. So this is another 0. So from power 4 to power 3, now you get power 2. Can someone give me the quotient here? What's the quotient in this? Excuse me, quotient in this case. 9x squared minus 4 equals to 0. So this is, and now you need to factor this. Can someone tell me what is the factor for this fellow?
3x. Minus 2.
And?
Plus 2.
So my question is, what are your zeros, your rational zeros in this case? What is your rational zeros? Anyone? 3x minus 2 give you what? 2/3, right? And this give you -2/3. What else? 3 and -2. So these are your rational zeros for question 2. Are these rational zeros, are these numbers one of these? Yes, 3 is here, -2 is here, and then 2/3 is here, 2/3. So those are all over here. So that's why, so this is how you figure this rational zeros out. Is everyone okay here? Questions? Is this coming up in your test on next week? The answer is yes. Okay, definitely yes. So I want you guys to do question 3 now. Give me your P's. Give me your Q's. And I'll give you a graph. Yes, in the test, I will definitely give you a graph. It's hiding over here. -4x cubed plus 15x squared. If I don't give you a graph, means the zeros, I probably not this one. If I have a lot of zeros like the previous question, then I probably give you a graph. This one, I don't think so you have that many choices. I don't think so this one. Nope, I don't give you any graph here. So if you have a lot of zeros, yes, I'll give you a graph. If you only have like a few of them, I probably won't give you a graph. So, Andrew, you are next. Can
Right.
you tell me what is P and Q here?
P would be -4, right? And
No,
Q
no
would-
negative, just
Oh, just 4, and then
no. P is the last number, the constant.
oh, I had it backwards. Okay, so
Yep,
P is
don't forget.
3, and then Q is 4.
Can you give me the factor for 3?
I'm not too sure.
So what times what is 3?
Oh, 3 times 1,
Okay,
so 3 or 1 and 3,
and then that's it, right? 4.
right? And then 1, 2, and 4.
Perfect.
Yep.
Now we're gonna divide this up. Okay. So what is your possible rational zero here? Andrew, you wanna figure this one out? You take this, divide by 1.
I take, what do? I take
The
1.
top divide by 1, and then top divide by 2, and then divide by 4. So what you get?
Okay, so it would be 1, and then 3,
Divide by 2.
3 over 2,
1/2.
or 1
first.
half, and then 3 over 2,
And
and
then,
then 3 over 1/4, and then 3/4.
yep.
Okay.
Thank you so much. And then what you need to put out front?
What was that?
What do you need to put out front? Plus,
Plus and minus. Yep.
Minus. Yep. So this is what you do in my test. All right. I think I'll draw them. So -4 will be the one that you syntactic with. 15, -8, and -3. And I probably give you, this is quite a lot of zeros. So I'm going to give you that 0, the graph. So this is the graph of question 3, the f of x. So can someone tell me what zeros should we use here to perform syntactically?
1 and 3.
So pick one, right? Don't do 2, just pick 1. So let's do 1. 1 is easy to do. So I want you guys to do syntactic division on 1. If you did 3, don't erase it. It's fine. The answer is correct. So go ahead and do syntactic division on 1. So you get -4. Only 6 people here? Where's the rest of my students? Andy, can you help me with the syntactic division here?
Yeah, -4, 11, and 11 again, 3, 3, and then 0.
Perfect. Okay. Now, what we do next is this is power 3. So this is when you do syntactic is power 2. So we're gonna do a factoring here. So the quotient here is gonna be -4x squared plus 11x plus 3 equals to 0. Now, usually if you want to factor this, we want to keep this as positive. So what do I do here is I want to multiply everything here with a negative so that I want the leading coefficient positive. But if you're using quadratic formula, doesn't matter, the leading coefficient is positive or negative. So, so make sure you know the formula. So I'm going to multiply everything here with a negative. And you begin to factor this fellow. Now, since because of the graph that we saw earlier on that I give it to you, that someone mentioned that 3 is a 0, right? So 3 is a 0. So that means that one of these will be x minus 3. Because then you get 3 as 0. So the other one will be 4x. Why is because 4x times x equals 4x squared. And this will be a +1 because 1 times -3 is a -3. So this will be your factor for this case, 4x squared, 4x plus 1 and x minus 3. So what are your zeros in this case? So your rational zeros. Oh, real zeros, they want. What will be your real zeros in this case? Anyone? Negative 1/4, 3, and don't forget your 1. So these are what we call as your real zeros. So real zeros and rational zeros are very similar. The only thing is that real zeros can include square root, and it can include pi, it can include all these icky numbers. But since we don't have this, so we do not have to worry about that. Okay. So this is how we find zeros here, real zeros. Anyone have any questions so far? Right. The next thing I'm going to talk about here is another important formula. So I'm going to put some checkpoint next to it. It's called a complex conjugate. Okay. What is complex conjugate is, this is for complex number. So if a plus bi is a 0 of the function, then the conjugate a minus bi is also a 0 of a function. So this is called a conjugate. That means that if you have a plus, the minus sign is automatically is a 0. Same thing the other way around. I'm going to put a little checkpoint here. Means that this is also very important. Now this conjugate pair does not only happens for complex, the I form. It also applies for square root. So that means that square root of 2 is a 0. Then negative square root of 2 will be also a 0. So this is also works for square roots. So it's not just I, it also works for square root in this case. So usually in the test, I always provide you one of this, like the a plus bi. So you have to figure out that the other one is also a 0. For example, in this case, is question number 5. So this question wants us to write a polynomial functions. So remember last time when I asked you to write a polynomial functions, we do the backwards way. So last time I give you the zeros, and in order for you to write the polynomial functions, you write this in the factor form. And then after you finish writing the factor form, you FOIL it out, then you get yourself the polynomial. So, so this is the type of questions that you need to watch out here, is because this one has complex. So for question number 5, how many zeros are actually provided to us? There are only 2 zeros provided to us, but how many zeros actually exist here? There should be 3 zeros because of the conjugate. Can someone tell me what is the conjugate of negative 3i? Hmm? 3i. Negative 3i will be what? Will be 3i. So this is the meaning of the complex conjugate. Usually I give you one, the other one is not given to us. So what we need to do here is you have to write this in the factor form. Do you guys remember how you write 4 in the factor form? How you write 4 in the factor form? Avery, you know how to write 4 in the factor form?
X minus 4.
That's right. How about negative 3i? Change your sign, right?
Would it just be X plus 3i?
Yep, you're correct. And 3i?
X minus 3i?
Yep. So don't forget, this is not given in here. Same thing in the test. I won't give you the other one you have to figure out. So so now you begin to FOIL it out. Now a lot of students try to FOIL these 2 out. I won't recommend you to do that. The reason why is because when you FOID those two out, you feel you will have a lot of i's exist. So I will recommend you to FOID the i's one out, because when you FOID the i's, they will kind of cancel each other off. So can someone tell me what happens when you FOID this for a while? So x times x is x squared, right? And then when you FOID x with negative 3i, you got negative 3ix. And then when you FOID the other one is positive 3ix. And then the last one will give us negative 9i squared. Now the middle term you find out, this is canceled. Does anyone remember what is I squared is? Anyone? This is important. So I squared in this case is -1. So this is one of the important complex you need to know, complex numbers. So that means this I squared is -1. So this is actually is x squared plus 9, because negative times negative is positive 9. And what you need to do next is, don't forget, you just FOID the last two. You need to drop the x minus 4, and you need to FOID one more time. So go ahead, FOID this last part. Hope you guys know how to FOID this. This is not that difficult to FOID. And I will ask you for that. What you get when you FOID this? Let's call Ethan. FOIDing this. Ethan, you there? Ethan. X to the power of
3
and then what?
minus 4x squared plus 9x minus 36.
Very good. Now, if you just give me this in your test, I will take half a point off. Does anyone know why I take half a point off? This is correct. But why I take half a point off? Because the question is asking us to find the polynomial function. So what is missing in front here? Forget this is important. I don't want you guys to lose half a point here. So the reason why I take half a point is because you forget to give me what? The f of x. Okay, so don't forget polynomial functions need f of x in front. If I ask for equation, then you put y equals to it. Okay, if a question is asking for find the equation, then give me y equals 2. Otherwise, give me f of x if it's a polynomial function. So make sure you read the question really carefully. All right, so I'm going to move on to question number 8 here. So question number 8 is asking us to find all zeros. All zeros means any zeros, complex, real, anything. So can someone tell me how many zeros is provided in question 8? You give us 5i, right? Only one. But don't forget, this is a power 4, so you need to have 2 zeros. So can someone tell me what is the second zeros here?
-5i.
Yes, that's good. If you give me this, automatically 1 point in your test. So that means you have to perform syntactic division on this and then negative on here. So we do 5i first. This is 2, -1, 49, -25, and negative. Yes, you can use complex numbers to perform syntactic. Okay, same thing. So drop the 2. So 5i, pay attention here, 5i times 2 is 10i. And we add this. Now we cannot add this because this is I form. So this will be -1 plus 10i. Okay. And now what we need to do here is we have to multiply this 2. Now, when you multiply 5i with -1, you will get -5i, excuse me. But when you multiply 5i with 10i, you will get 5 times 10 is 50i squared. But you know that I squared is a -1, so this is actually is -50. Okay, so make sure you guys change the I squared to become -1, so that's why it become -50. Now we add this again, -5i, you cannot add it, but this 2 you can add it. So 49 take away 50, you get -1. And then you distribute again, 5i times -5i, you get -25i squared. And don't forget, this I squared will make him +25. And then this times -1, you get -5i. So when you add this will cancel out. So what we left in this case is -5i. And this 2, when you multiply, you get -25i squared. But again, I squared will make him +25. And when you add this, it becomes 0. Okay, so this is your first 5i, your zeros. So the next one you have is a -5i. Now, when you perform the next complex 0 here, the conjugate, your remainder here is going to be nice. Nice means it doesn't have any more I left over. Okay, so you put 2 here, this times this become -10i. So this will cancel out, we get -1. This is what I mean. It doesn't have any more I left over. It's very nice. So this times that will become 5i. And this 5i, -5 cancel out, you get -1. Very nice. And then this times this will become 5i. This will become 0. So what I want to tell you guys here is that if you perform the conjugate, the twice here, this next time you do it is I-less. That means it doesn't have any complex number involved. And then what you do here is you can factor this one out. 2x squared minus x minus 1 equals to 0. So can someone factor this for me? Anyone can factor that?
2x minus 1.
2x minus 1 and what? X plus 1?
Yep.
Is this correct? 2x, you can FOIL it up, check it, right? 2x times x, 2x squared, 2x times 1 is 2x. Always check the middle one. Minus x. So unfortunately, this is wrong because you get x, but we got a -x. So how do we fix this? This is wrong because you get x here, you do get -x. So how do we fix this? Very easy to fix it. Anyone? Change your sign. So instead of 2x minus 1, this is 2x plus 1 and x minus 1. So if you FOIL it out, if you find your middle term, difference is only the sign. This is negative, you got positive. When you FOIL it out, just switch your sign around. So what are your zeros here? All zeros. X equals to what? -1/2. X equals to 1. And don't forget what else? The 5i and the -5i. So this is your answer in this case. Now, class, I want to point out to you is if I use my graph to graph this function out, do you think the 5i and the -5i will show? You think the 5i and the, oh my God, come on. This is what happens when I try to hide things. Now down here, there you go. So you think the 5i and the negative 5 will show in the zeros? Anyone? If I graph this graph, 2x to the 4th minus x to the 3rd plus 49x squared minus 25x minus 25. Do you think they will show the complex zero? Do they show this negative half and 1? Yes, they will show this negative half and 1, but do they show the I form? Do they show the I form, class? No. Okay, don't forget, when you graph something, this is all real numbers, not complex. So a graph can only show the real part, it cannot show the complex part. So if I give you a graph like this and you only show 2 zeros, but we know this is a power 4, right? Power 4 should have 4 zeros. So what happened is that the other 2 has to be complex, okay? And the other 2 is real because the real one is shown in this graph here. So this is what happens, just very important here. So if I give you a graph and only give you 2, but this is a power 4, that means 2 of them has to be complex. And it's not shown in the graph paper, in the graph. You guys got any questions for me here? Anyone have any questions with this? So you see a lot of synthetic division here, right? So make sure you guys know how to do those. Anyone have any questions before we move on to chapter 4.1? This is the most important thing in chapter 3 is what I showed it to you here, which is the 2 important theorem that we talk about, the rational zeros and the complex conjugate pairs. So these are the 2 important theorems. So make sure the rest of that I didn't go over is not that important. So it's in your homework, but it's not going to be in your test. So you make sure you read through it. You can also search on YouTube like the Carter's rule of sign. You can just type in there and they will show you what it is, upper lower bound rules. So those are the rules that we have. So I would recommend you to search on YouTube. Otherwise, just ask me and I will show it to you how to do it. Because we're going to move on to chapter 4.1 here. So we're going to talk about 4.1. So chapter 3 and chapter 4 has nothing to do with each other. So just like, so make sure you guys know that once you move to chapter 4, we don't do a little bit of chapter 3, but not a lot. So there are 2 a little bit different subjects here. So before I start with chapter 4, I want to take attendance. So go ahead and go to the chat room and type present here. Okay. So we're going to talk about 4.1 here. So this is talking about rational functions and asymptotes. So what is a rational function? A rational function is where they give you a quotient of 2 polynomial functions. That means that you will get polynomial functions on top, and you will get a polynomial functions on the bottom. So example of rational functions in this case will be like f of x equals to like 3x plus 1 over by x squared minus 4. This is a rational functions. So in order for us to do this, you have to go through a few things. 1, how you figure out your domain. 2, how you figure out your asymptotes, which is this one. And 3, how you graph this. Okay, so 4.1, we will talk about this, the domain and asymptote. 4.2, we'll be talking about graphing. So don't forget your Monday, we'll talk about graphing. So today we'll talk about this, the domain and asymptote. So do not forget that your domain here is always all real numbers, except your denominator cannot equals to 0. So looking at this function, the example I give to you, can someone tell me what is the domain for it? What's the domain for that fellow? What will make the what x value when you plug in will make him 0?
All real numbers, x cannot equal 2 or
And
-2.
yep. So x cannot be 2 and -2. Okay, because when you set this equals to 0 and you solve for x, you get this 2 and negative. Now, how do you write this in your homework? Because some of you still have trouble writing this. So if a domain is all real numbers, how do you write this in your homework? It goes from negative to positive. This is how you write this for all real numbers in your homework, in what we call as interval notation. How do you write this in your homework? In the test, yes, I take this. You don't need to write this in a fancy way. But in your homework, you might need to write this in the interval notation. So how do you write this? So you remember, any number works, -2 cannot works, and 2 cannot works. So how many interval notations you have to write? You do have to write 3 of them. So can you write me the first one here? What is the interval notation for this case? Negative infinity to where? To -2, followed by what? Union. What is the middle one? Suksa? What's the domain for this in an interval notation? -2.
2 and infinity.
No, don't forget, this is not
Oh, I
this is
meant
just the 2. And then what's the last one?
negative.
No, this is the last one. This is the last one.
Oh, sorry, 2.
To what?
And then the little infinity sign.
To
yeah.
infinity. So this is how you write a domain that is, you have 2. So you have three interval notations in this case. One in the left, one in the middle, one in the right. The one on the left always goes to negative infinity. The one on the right goes to infinity. The one in the middle goes to middle. Okay, so this is how you figure out your domain. We talked about that before. So now we're talking about asymptotes. So there are 3 types of asymptote. One is called a vertical asymptote. One is called a horizontal asymptote. And one is called the oblique, or sometimes we call the slant asymptote. Now, the oblique or the slant asymptote will be taught in 4.2. So if you have an oblique asymptote in 4.1 homework, you just say D and E. Okay, I will show it to you what I mean by that. So how do you figure out your asymptotes is first thing first, this is very important. Both of your numerator and your denominator has no common factor. What does it mean by no common factor? Means that you have to factor this out, if it's factorable, and cancel. So, so when you have rational functions, in order for you to find asymptotes, you have to factor them, and then if there are any same common factors, you will have to cancel those common factor out. So in this case, if you look at here, can we factor 3x plus 1? Can we factor here? We cannot factor 3x plus 1, so you should leave it as that. Can you factor x squared minus 4? Yes, we can factor. And what is a factor for x squared minus 4? This is easy. You should know this.
X plus 2, x minus 4.
X plus 2 and x minus 2. So you figure out that anything can be canceled here. Are they common? There is no common factor. So this will be your the what we call it as a simplified form that we need. If there is a cancel, let's say these two are the same, then you have to cancel it. Then you just get 1 over x plus 2 if if these two are the same. Okay, let's say. So unfortunately, they're not the same. So this is your no common factor in this case. So how do we find your vertical asymptote? So this is something that I would recommend you to, if you guys want to study this for the test, this is 4.1, this is chapter 4.1 and 4.2. This is important. And if you doesn't know this, 4.2 needs this. Okay. So how do we do this? Is in order for you to find the vertical asymptotes, you find the zeros of the denominator. So you set your denominator equals to 0 and solve for x. How do you figure out your horizontal asymptote? You look at your powers, your n and m. You know, what degrees do we have? So if your n is smaller than m, then y equals 0, your x-axis will be your horizontal asymptote. But if your power is exactly the same power, then y equals to an bm over bn is your horizontal asymptote. What is an and bm? An is your leading coefficient on the top, and bm is the leading coefficient on the bottom. So you just do the ratio, the division. What happens if n divided by n is more than m? That means the top power is greater than m, the bottom powers. We will call no horizontal asymptote. So when you do your online homework 4.1, if you have such case, you just record this as D and E. But when you do your 4.2 and your test, then you will report that we will have a Slane asymptote. And in 4.2, you have to find it. And in order for you to find the Slane asymptote, you have to perform syntactic division. Okay, so so this is how you find the Slane asymptote. Is usually you perform syntactic division. So this is something that is very, very, very important in this class and in this chapter 4. Okay, so for example, here is if you look at this. So now we figure out your asymptote. So how do you find your vertical asymptote? You can short form the test, BA. You set your denominator equals to 0. So this is your denominator. You set them equals to 0. So can someone tell me what is your vertical asymptote here? Solve for x. What you got?
-2 and 2.
Now, a lot of you will put this in my test or homework, -2 and 2. So if you put this in your homework and your test, they will mark you wrong. So listen carefully here. It's not wrong, it's correct. The reason why they will mark you wrong in this case is because asymptote is a line. So you have to put x equals 2. Okay, so this is, so make sure you guys know that when you do the asymptote, no matter it's vertical, Slane, or horizontal, you have to put x equals 2. For horizontal is y, so vertical is x equals 2, something like 2 and -2. Horizontal will be y equals 2, as Slane also y equals 2. So make sure you put x and equals to y equals 2. Same thing in your homework, same thing in your test. Otherwise, I take points off. Now, in order for us to figure out, do we have which case we have, 1, 2, or 3, you look at your powers. What powers do we have on top? What is your degree? So this one only have power 1. And if you look at the bottom one, if you void this follow up, what power do we have on the bottom one? You can look at the top one here too. This power is what? Power 2, right? So in this case, we know n is less than m because 1 is less than 2. So if you look at this condition here, which one are we taking? A, B, or C? Since we have this, so are we taking A, B, or C? This is the condition we have. So which condition, which one? A, B, or C? Avery?
Horizontal asymptote of y equals 2?
No.
Or y equals 0, sorry.
Yep, this is the A. So because n is less than m, so in this case, you will have a horizontal asymptote of y equals to 0. That's correct. Okay, so so now I'm going to tell you what is a vertical and what is a horizontal asymptote. So when I say a vertical asymptote, means that it is a vertical line. It will be at -2 and 2, and this graph will not cross on this line. That means the graph can go up to the positive infinity, or it can go down to -infinity. So this is what we call as a vertical asymptote. So as the x getting closer and closer to this value, it will diverge to negative or positive infinity. That means it won't touch it. Same thing here. It can go down here. It can go up here. Depends on well, what do I do here to figure out, are they going up or going down? And then for horizontal asymptote of y equals to 0, it means that at this point, the graph will be diverged, either going up, will be getting closer and closer to this x-axis at y equals to 0, and it will go, so that means that it is possible to cross at the horizontal. So that means that it is not possible to cross this. So it means you can never cross them on the vertical. But for the horizontal, it's possible this graph can cross it. Okay, so we will talk about this when we do the graphing, if it's crossed or not. So the question is, how do we figure out, are they going up or down? Is what we call as the behavior of the f. Okay, discuss the behavior of the f. So what we're doing in this case is we look at a number that is very, very close to the -2 on the left side. Forget, this is the left side and this is the right side. So can you tell me what number is close to this -2 on the left side? What number is on this side? Now, -3 is here, so we do not want to use -3 because -3 is not close enough to negative on this side. So what number is so close to this side? Negative. Anyone got a number? What number is close to here? 2.0001. So these are the numbers that is close to it. So we call this as -2 minus. So when you have a minus, means it's telling us on the left side. So what do I do in this is I plug this -2.0001 into this function and figure out, is this going to become a negative or positive? So when you plug -2.001 here, and if you multiply this by 3 and add 1, do you think this will be a positive or negative number? That's what I'm asking. So when you plug -2.001 times 3 and then plus 1, is this a positive or negative number? Anyone?
Negative.
This will be a negative number. You repeat the same thing. Put the -2.001 into here. You think this will turn out, this factor turn out negative or positive? Where's -2.001 plus 2? That will also give you a negative. And then because -2.0001 minus 2, is that negative or positive? So this will definitely become negative. So if you look at this, if you do know your multiplication, negative times negative is positive. And when you divide negative with positive, this is -infinity. So you get -infinity. So what is going on here is on the left side here, this fellow will goes down. No, not goes up. And the reason why is because when you put -2.001, the number is actually getting a -infinity. So how do we write this is when x is approaching -2 minus, which is on the left side, your f of x in this case will approaching -infinity. So this is how you write here. This is important, and I'm not kidding you. You need to know this when you do the next section. And next, we're gonna figure out what is the number that is on the right side. Can someone tell me what number is on the right side of -2? What number is close to -2 on the right side? And we call this as -2 plus. So minus on the left, plus on the right. Anyone know what number we use here? -1 point what? 99999. So if you put -1.999 into this x, will you get positive or negative? 3 times -1.999 plus 1, negative or positive number? This will give me a negative number. And then you do the same thing, -1.999 plus 2. This will give me a positive number. And then -1.99 minus 2. This will give me a negative number. So if you remember last time when you do multiplication, if you got 3 negative, you will get a negative. What happens when you get 2 negative? You get what? Positive or negative? This will get a positive infinity. So that means this graph will go up, not go down. And you have to repeat this over and over again. So on this side. So how do we write this? Is when x approaching -2 plus, your f of x will approach positive infinity, means it goes up. And you're gonna do it 2 more times. One is on this side and one is on that side. So can someone tell me what is this value will be? 2 minus. Anyone? Avery?
1.999.
Yep, 1.999. So now you have to plug in 1.9999 into this x. So what is 3 times 1.99 plus 1? Is that positive or negative number? Three times 1.99 plus 1. That should give you a positive number. What is 1.9999 plus 2? Positive. And what is 1.99 minus 2?
Negative.
Negative. So do you get positive or negative if you combine all these sides together? You will get a negative infinity because only one negative here. So that means negative infinity means this graph will go where? It will go down, not go up. And how do we write this? When x approaching 2 minus on the left side, f of x goes to what? Negative infinity. And the last one, I'm going to use pink. So what number should we use on here? This is called 2 plus because on the right side. 2.0001. And plug this into your x's. And you notice that everything here will become positive. So that means that this will go to positive infinity. I'll just save time. So that means this graph will go up, not going down. So how do we write this? Should be written down as when x approaching 2 plus on the right side, f of x will approach infinity. Why this is important is because we already know the graph, what it looks like. This graph, it will look exactly like this. You got the -2, you got a +2, and you got the 0. And then if you look at the blue, the first one, this fellow says it goes down. And then the purple one says this fellow will goes up. And then the orange one here says it goes down. And then the pink one says it goes up. So if I want to draw a graph, and we know you cannot cross here, so this fellow will go somewhere like this. It's like a boomerang. Now this one, because it go up and down like this, so this one might look like a power 3 graph. And since this is through the midst, it will intercept here, and this fellow will go boomerang like that. So this graph 3x plus 1 over x squared minus 4, this is what the graph looks like. And again, you will learn this in 4.2. But as you know that in order for you to graph it, you need to know how the behavior works. That means, are they going to positive or negative infinity on the left and right side? And what I'm showing you here, the left and right side here, is on calculus 1. We call it as limits. So when you go to calculus 1, you will notice we are doing this. Okay. So this kind of questions is what we did in number 1 here. So so you have to figure out what we call as the domain, which is the domain we find out, and the end behavior that we did here. Okay. So it's a lot of work here. It's difficult. I didn't say it's easy. Okay. But you need to practice. So hopefully you can practice a bit more here. And all the stuff that you learn here will be used in 4.2 on Monday class. So we'll do a little bit more work. You can, yeah, I think this is the one. So we'll do a bit of 4.1 here. Because Monday we'll do 4.2. Question 2. If you read the question, it's asking you to find the vertical and the horizontal asymptote. Can someone tell me what is your first step when they ask you to do this? Find the vertical and horizontal asymptote. What is your first step? Do you remember that? Where's your first step?
And the domain?
No, we don't find the domain. This question doesn't ask for domain. This question only asks for asymptotes, vertical and horizontal asymptote. So how do we find that? First, you have to perform what? Factor and cancel, right? So can you factor x minus 4? No, we cannot factor this. Can you factor x squared minus 16?
X plus
Yes.
8.
Not 8.
4, sorry.
4, right? Plus and minus 4, right? And what do you find out here when you factor that? They've been canceled. There's a cancellation, right? Because there's a common factor. So how do we write this since they cancel? Is 1 over x plus 4. That's what we left. And x cannot be 4. Where is this 4 come from? This 4 comes from the one that you cancel. If you solve x minus 4 equals to 0, you get x equals to 4. So that means that this is what we call as whole. So when you draw a graph, if you got cancellation like this, your graph, don't remember last time we draw a graph like a boomerang. So at 4, this has a hole in there. So that's the meaning of it. Okay. So now you need to find the vertical asymptote. So can someone tell me how you figure out your vertical asymptote? Set your denominator equals to what? 0. So we don't since we cancel this, we just look at this fellow. This is the new functions that we have. So can someone tell me what is your vertical asymptote here? X equals to what? -4, right? Don't forget, if you give me -4, I will mark you wrong. Okay, it's x equals to -4. So the next thing you need to point out here is to figure out your horizontal asymptote, which ABC, right? So first you have to tell me what power do we have. Can someone tell me what power is this one? What power is this? Do we have any x on top here? So no x, the power is 0. Don't forget, this is power 1. This is power 2. So if you don't have any x, power 0. And what power do we have on the bottom? The denominator. That power is 1. So is n is what? 0 and 1. Is 0 is less than, equal to, or greater than 1? Which one is it? A, B, or C? Anyone? So that is, n is what? 0 is what? Come on, this is easy. Less or equal, that greater than. This is less, right? So which one are we taking? A, B, or C?
A.
So that means you will have a horizontal asymptote of what?
0.
Not 0. Y equals to?
I equals 0. Yeah.
Yep. So don't forget, as I say early on, make sure you give me x equals to for vertical and y equals to for horizontal. Okay, and that's your answer. All right, let's do the last one, then we stop. Number 3. Can someone factor the top one? X squared minus 3x minus 4.
X minus 4, x plus 1.
Okay, that's good. Now we're gonna do the factor for the bottom one. So I think we did this before. This is 2x and x, and this is 1 and 1. So one of this is plus and one of this is minus, because you get a negative one. And we need to throw it out to double check. 2x times x is 2x squared. 2x times negative 1 is negative 2x. 1 times x is positive x. So this will give me a negative x. Is this a correct factor here? For number 3. Is this correct? This is wrong because you get negative x, but I want what? Positive x. So how do I fix this?
Switch it.
Switch it. Yep. So this will become minus and this will become plus. So can we cancel something else here?
X plus 1.
X plus 1 can be canceled. So in this case, the new one, the new function here is x minus 4, 2x minus 1. X cannot be negative 1 because we cancel that below. So can someone tell me what is your vertical asymptote? Your vertical asymptote, you set your denominator equals to 0, what you get? Set this equals to 0, what you get? Forget x equals to 1/2, right? Don't forget x. Now we look at your power for the ABC. What power we have on top here? This power is 1, because it's the power 1. And what power we have on the bottom is also 1. So in this case, n is equals to m. So are we doing A, B, or C here?
B.
So it's a horizontal asymptote. Now, if you pick, this is a B, that is correct. What is an over bn? An is the leading coefficient. What is your leading coefficient on the top one? The leading coefficient is 1. Do you see that? And what is the leading coefficient on the bottom one? Is 2. So what is your an over bn? Is 1/2. So in this case, your horizontal asymptote for this case is y equals to 1/2, because the leading coefficient is 1 and 2. You guys all right here? How you do the part B part? We look at the leading coefficient, and you ratio it, you divide it. Questions for me here, class? So this is very, very important. So I'll put checkpoints again. There's a few checkpoints I want to point out because this is important. So make sure you guys understand this. So don't forget, you have 2 homework due tonight, 3.2 and 3.3. And then you got 3 homework due on Tuesday, actually, 3.4, 4.1, and 4.2. Okay, just want to point out to you guys, you got 3 homework due on Tuesday. The reason why I make your homework due on Tuesday, not Wednesday, usually your homework due on Wednesday, right? The reason why I do it on Tuesday is because next Wednesday you have your first test, and your first test does include 3.4, 4.1, and 4.2. So make sure you guys do those homework before you take your test. It's got to include those. So I'm going to stop sharing here, and I will definitely stop recording here.